Alright, what's up guys? In this video we're going to pick up some calculus here. We're going to do some higher order implicit differentiation. So we're asked to find d2y over dx squared given the implicit function x squared plus y squared is equal to 1. So if you don't know how to do implicit differentiation, I do have other videos on it. It's a pretty straightforward process, but it does take obviously a little bit of practice to run through a few examples to kind of get the hang of the whole process. So check out my other videos on that. So in this case, to find d2y over dx squared, we're going to find the first implicit derivative, then we're going to do it again. So obviously this is not the best video to look at for implicit differentiation for the first time. So we'll begin by finding the first implicit derivative, and we begin by differentiating both sides with respect to x. And remember, what you do is every time you differentiate y, you multiply by dy over dx. So begin by finding the first implicit derivative. So let's go ahead and do that and see what happens. So in this case, we obviously get 2x plus 2y, but we got to multiply by dy over dx. And that's going to be equal to 0. And really, that's the only algebra, or excuse me, the only calculus that's actually involved in it, is taking the derivative of both sides in the beginning. And then after that, it's just a bunch of algebra because you're just trying to isolate the dy over dx. So in this case, let's go ahead and subtract 2x from both sides. So if we do that, we'll get 2y multiplied by dy over dx is equal to negative 2x. Okay. Now we can divide both sides by 2y. So we'll have 2y multiplied by dy over dx. We'll divide that by 2y. And then we divide this other side by 2y, which is negative 2x. We divide that by 2y as well. And what that does is it isolates dy over dx for us, which would give us our first implicit derivative. And so if we simplify over here, we just get negative x over y. So that's the first implicit derivative. So that was pretty straightforward. Again, these can get a little bit more complicated. I do have videos on where we just, take the first implicit derivative where it requires a little bit more work. So these can get pretty complicated depending on what kind of problem you're working on, but this one's pretty straightforward. Okay, so that's the first implicit derivative. Now I need to do it again, okay? So to do it again, what we're looking for is, again, we're looking for d2y over dx squared. Again, that's just the derivative with respect to x, negative x over y. So approach this no different than how we approached it to get our first implicit derivative. It may seem a little different, but it's not super different here. Okay, so in other words, what we're looking for, d2y over dx squared, that's what we're looking for, is dy over dx for dy over dx. So the first implicit derivative here was dy over dx is equal to negative x over y. Well, to get d squared y over dx squared, we're looking for dy over dx of dy over dx. That's how we get d squared y over dx squared. Okay. All right, so we need to differentiate with respect to x, negative x over y, again, multiplied by dy over dx every time we differentiate y. So to do this, we'll have to use the quotient rule. Let me remind you of what that is. So if I want to take the derivative with respect to x of, let's say I have f of x divided by g of x, well then the quotient rule is just going to be f prime of x multiplied by g of x minus f of x times g prime of x, and that's going to be all over g of x squared. So that's the quotient rule. Okay. So we're not going to have enough room to do everything on this sheet. So we'll go to the next sheet here. Alright, so let's see what we get. d2y over dx squared. We'll use the quotient rule. The negative can stay on the side here. So if we use the quotient rule, we'll get 1 times y minus x times dy over dx. And that's going to be all over g of x squared, which is just y squared. And we can clean this up. So this would just be d2y over dx squared. It's going to be equal to, if we clean this up, we'll keep the negative to the side, of course. And then this will be y minus x times dy over dx, all divided by y squared. Now, if you recall, back to the original implicit derivative, recall that dy over dx was negative x over y. So we now substitute that in up here and see what we get after we do the simplification. So we get d2y over dx squared is equal to, we still got our negative to the side here. And so now we got y minus x multiplied by negative x over y. And then that's going to be all divided by y squared. And we clean it up and we see what we get. So we'll get d2y over dx squared. So we still got our negative. We keep that to the side. And then we simplify and we see what we get. So looks like we're just going to get negative y squared plus x squared. If we simplify, and then this would be y cubed down here at in the bottom, in the denominator. Now recall that since multiplication, that since addition is commutative, if you want to write it as d2y over dx squared, you can write it as negative x squared plus y squared all over y cubed. That's perfectly fine too. It's the same thing. Now you may say, okay, well this is our implicit derivative, but if you go back to what we were given at the beginning, recall that x squared plus y squared was 1. So in this case, in the numerator, since we're given that x squared plus y squared, what we can do is replace this with a 1. And so actually d2y over dx squared would just end up being negative 1 over y cubed. And that would actually be your implicit derivative. So your final answer for this is just going to be, our second implicit derivative will be d2y over dx squared is going to be equal to negative 1 over y cubed. That's your implicit derivative, and that's your answer. All right. So let me know if you guys got any questions about this. Again, you'll need to do a couple of examples to kind of get the hang of this whole implicit differentiation thing, but I don't think it's actually that bad. As long as you obviously go through a bunch of examples, and you need to be good with taking derivatives. Obviously, that's obviously going to be a big deal here. But relatively simple derivative taking here. Not much going on here. All right. So if you guys got any questions, let me know. I'll be more than happy to help you, and I'll see you next time.